मनीष शुरू करे क्या?
हाँ डॉक्टर साहब करते हैं। पार्टिसिपेंट्स तो जुड़ रहे हैं।
जुड़ रहे हैं अभी। हाँ
मिनट्स और वेट कर लेते हैं स्टार्ट
हाँ 3 मिनट और वेट करें।
हाँ डॉक्टर रोमन, थोड़ा सा वेट करने की, आई हैव पुट इट फॉर स्टूडेंट्स आल्सो, दे मे ज्वाइन। Our students will also join.
Yes, sir. Yes, sir.
Okay. Some have joined actually.
Okay, sir. I think we can start, I think.
Yes, sir.
So, good evening, everyone. Welcome to day 3 of our 21 days online training programs. Today we have two experts, one by Dr. Selvarangam Venkatesh from Koteba Agri-Science and the other by Dr. Subi SB from ICAR-IIMR. To begin with, it is my privilege to introduce Dr. Selvarangam Venkatesh from Koteba Agri-Science. Dr. Venkatesh is an experienced maize researcher and breeder with expertise in corn genetics, hybrid evaluations, and product development. And his work has significantly contributed in advancing high-performance maize hybrid through innovative maize breeding and evaluation strategies. Sir, since your lecture is on breeding or breeding for enhanced starch and ethanol for maize, and this is highly relevant, sir, in the current context with the growing economy, with emphasis on bioeconomy, and will provide valuable insight into developing maize hybrids with improved starch content and ethanol production potential, sir. So may I now request Dr. Venkatesh to kindly deliver his lecture, sir.
Yeah, sir, please confirm whether my audio is clear.
Yeah,
Yes,
Dr.
yes, sir.
It's very much clear.
Okay, then what I'll do in the interest of the bandwidth, because I'm working from home today, so I will share my PPT video. I'll keep it on mute. So just confirm, sir, that my presentation is visible.
Not yet, sir. Yeah, now it is okay, sir. You can put it on the screen share mode.
Okay, fine. So good evening, all the participants, and thanks to IIMR for inviting me for this lecture on breeding for. Yes, sir.
This video, this
No,
PPT.
only the first slide is the video. Others
Okay.
are all the normal slides. So,
But
yeah.
okay.
Is it clear, sir? No, my slide deck is visible.
Yes, sir.
Yes,
Yes.
So, good evening, friends, once more. So, I will be taking the next 45 minutes from your end for presenting this topic on enhancing starch and ethanol from maize, essentially through the breeding activity. So, before we go into ethanol and starch, I would just like to briefly mention about the utilization of maize.
Excuse me, sir. This is not into the this full screen mode, so we are unable to see this actually.
So now for me it is in full screen mode on my.
No, it is in full screen mode only.
Dr. Saab, it's full screen. You can proceed. There's no issue.
Okay, so basically I would like to dwell on the maize utilization in India. We know that poultry feed is a major component of maize utilization, and that is around 55% goes into the feed essentially for poultry. Then starch industry consumes about 20% to 25%. Ethanol, of course, is vastly enhanced in terms of its utilization because of the E20 blending by Government of India. And then other major shift has been with this ethanol piece from a commodity, it has grown into an industrial molecule, particularly the ethanol component of corn. So when we talk about processing corn, we'll have to be very wary of the kernel composition in corn. It has about 60% to 70% starch, 8 to 10% protein, oil is about 3 to 5%, and fiber is about 10 to 12%. So essentially the starch in the endosperm, it drives the ethanol extraction. Then the milling, we know there are two types of milling, the dry milling and the wet milling. And for the dry milling, the kernel hardness, that is the vitreosity of the corn kernel, it affects the milling efficiency. Then the protein in the corn endosperm, it impacts the feed efficiency. And there are several variables here. One is the moisture variability. Other one is if the grain is not stored properly, there is an aflatoxin risk, which is deadly for the cattle or the other feed activities what are there for poultry, etc. Then the supply chain needs to be very much integrated, because if the supply chain is disrupted, then the entire industry backup for the grain will be impacted. So these are some of the key things we need to keep in mind. Then this slide shows about the dry milling process, because in processing, we know that the dry milling is a key activity where they clean it, degerm it by soaking it in water, then grind it, then sieve it. Then the grits are, there of different sizes which are used in the poultry feed. So essentially the endosperm is the major component for the protein and starch, and the germ is one for the oil. And we know that the different types of corn will have different proportions of the embryo to endosperm variation. Then the imperatives in dry milling include the mills which should be distributed across rather than centralized. They should be decentralized. There should be a high variability, as I said, in case of the efficiency with regard to the grain type. And then the kernel hardness is a critical trait for dry milling. So these are the things which will come into dry milling. Of course, the topic of today is not about the processing efficiency, but just I would like audience to know about dry and wet milling. The wet milling process flow, here you use the water soaking, germ separation, fiber removal, starch extraction, and the byproducts, essentially from the same components of the corn grain. So here, high value extraction is very much premium. Then starch recovery is a key aspect of the wet milling process. And then the water and energy intensive process is wet milling. So these have to be adequately sourced for the wet mills to run properly. Then when we come to the other main topic of today, that is ethanol. So here also, the grinding of the grain, liquefaction, that is soaking, and then saccharification, fermentation, distillation, and then getting the grain solids in place for after fermentation, ethanol is got by anaerobic fermentation. So here, the Government of India has a big push on E20 blending. Then, of course, there is a poultry feed versus the ethanol partitioning, but then we know that if the production increases substantially, we can meet both the sectors. Then we know that the grain solids, which are important co-product, can also have utilization for ethanol extraction. So basically, what value we are saying in terms of maize adding value is the yield, which is high yield, is leading to higher starch percentage in the grain. And then we'll also have higher recovery if higher yield is there. And then if we are able to incentivize by giving about 300 to 400 rupees extra per ton, then that will incentivize the farmers to really go in for larger acreage of maize. And then thereon we can give to the different stakeholders. And we know that we need to do breeding, not just in terms of yield, but in terms of what are the needs of the processors and what we need to do. Then we need to integrate our breeding activity with regard to the market requirement and about the processing industry requirement. And then we'll have to focus on stability of the extractable components and also the quality of the components. So for this, there are network of biorefineries or distillery plants, what we have. Then another important aspect is silage is expanding, particularly in northern part of the country. Punjab is one good example. Haryana is another example. And some part of it is expanding in Maharashtra as well. And then the specialty starch products. Starch can be hydrolyzed through acid or enzymatic means, and then it can lead to a large number of products. We all are aware that corn can give more than 500 products by processing the corn grain itself. Then the other key thing is ethanol. First part of my presentation would be on focusing on breeding aspects for ethanol, and then other one would be on the starch component. So we know that there are different generations of biofuels, and essentially what extraction of ethanol from corn as a biofuel, we are saying this is the first generation biofuel. There are, of course, other second, third generation biofuels, but interest of time, I will not dwell in it. I will just give this presentation to our organizers so that they can post it on the thing. So essentially, the ethanol procurement price is about 71.8 rupees per liter, and this is highest for the feedstocks. So this is one key component driving the investments there. Then grain-based ethanol, both maize and the split rice, is a large and growing part of India's ethanol capacity. Now almost sugarcane and corn and grains are 50-50 now, almost. And then in 25, 431 crore liters are over 51% of the total ethanol supply by the OMC tenders was from the grains. Then in 2026, the grain-based ethanol has slightly overtaken the sugarcane as a ethanol component, and we got 50% of the total ethanol from maize. And there are policy shifts with regard to the government restricting the sugar diversion. That also boosted the maize ethanol demand. And of course, now all recognize maize as central to achieving our E20 blending targets as of now. As we move towards 2030, it will be towards E30 blending in fuel. So almost 12,000 crore has been added in terms of rupees to the GDP by the maize-based ethanol. And it has saved our import bills as well, because we have stopped importing commensurately higher crude oil components. And then the pricing incentive. Last time the MSP price was about 2,400 rupees per ton, and that also spurred maize cultivation and thereby the investments in ethanol plants and the production scale up. So here you can see very clearly from grain and from sugarcane, you can see almost neck to neck till 25. And this year, slightly we have an edge for maize over the sugarcane derived ethanol. Then you know that today from about 67 crore liters in 2015, today over 637 crore liters of ethanol is being produced in India. And the CAGR, as you can see here, is well over double digits. It's about 18.9 in 25-26. Then what are the major maize producing states or the ethanol distilleries and the ethanol producing states? You can see here, UP is about 250 crore liters, Maharashtra 158, Karnataka 129, Bihar 100 crore liters, Tamil Nadu 95 crore liters. These are the top 5 states, and closely followed by Gujarat and Telangana as well. So there will be total estimated ethanol production for all states would be about 1,700 crore liters close to, and that is an increase of 5%. And I think this year we are close to about 8% in terms of the ethanol increase. Then we know that, this green chart of India map shows how much is the ethanol share in our state's petrol. So you can see that UP, MP, Odisha, Maharashtra, AP, Haryana, all these have over 18% of share in the petrol, close to 20% blending there. So that is very good augury, and we'll optimistically look forward towards the 30% ethanol blending. And you can see in 2014, it was only about 1.5% blend, and 25, it was a 20% blend in the fuel, petrol especially. Then we can see this is the blending targets. As we see in 2030, we'll have about 50%, about 30% blending up from the current 20%. Then what are the key factors as a researcher for maize breeding? One is the grain composition and the ethanol efficiency, how the ethanol yield translates to industrial processing, and maize ethanol benchmarks. So what are the benchmarks, what we'll have, and what are the policy supports, what we need from the government. So here, what are the grain components which will be useful for ethanol extraction? One is the starch, which is about 65 to 72%. Generally, the post-rainy corn, the spring corn, and the rabi corn will have more temperate components, so more starch extraction is there. Whereas the temp crop mix in the rainy season makes it in the mid-60s starch recovery. In general, I'm saying. Then protein is about 8 to 11%, what I said earlier as well. And then protein is a byproduct as a DDGS, as a grain solid, which affects the starch dilution as well. Oil percentage is about 3 to 5%, and it's an energy co-product, and it does have a minor fermentation effect only. Then the fiber, of course, more fiber means low fermentability. That's about 7 to 9% of the corn grain kernel. And then the ash and other components will be 1 to 2%, which are negligible. Then in starch, we know there are two major components, amylose and amylopectin. So one is amylopectin is about 70 to 75%, highly fermentable. That's very desirable. That's why we say that waxy corn also is very desirable for the amylopectin, because complete thing in starch is amylopectin there, and then we can have better ethanol extraction through fermentation. And then when amylose content is about 30%, and it has a slower enzymatic hydrolysis, so that impedes rather amylopectin will facilitate. So amylopectin has a branch structure of starch, unlike amylose, which has a straight structure. Alpha 1,4 linkages are there in amylose, whereas beta 1,6 linkages are there in amylopectin. So higher ethanol yield, the higher yield means higher ethanol extraction. So as I said already, waxy maize is very much amenable for amylopectin, which is 100% there in the starch, and it gets 3 to 5% more ethanol. But then the yield component of waxy maize is not as competent as the normal maize, which has more blending of amylose. So what are the components? The endosperm, germ, pericarp, and the tip cap. These are the four key components of the kernel of corn. So endosperm is the major starch reservoir with about 80 to 85% of the kernel. Germ is about 10 to 12%. Pericarp is 6%. Tip cap is of course 1%. That is negligible. So endosperm again can be of different types. We know dent corn, flint corn. Mostly we use semi-dent or semi-flint corn, and the type of the endosperm texture, it affects the milling efficiency and the ethanol yield. So when the dent corn is there, it gives higher ethanol yield. Semi-dent corn gives a moderate ethanol yield, but then that's also, less impacted by the storage pests as well compared to dent corn. Then the flint corn, of course, is very good for storage, but of course there is lower yield and high energy cost to recover the ethanol from that. Then the softer endosperm facilitates easier grinding of the grain, and then lower enzymatic dose is required to ferment that, and then faster starch gelatinization happens there. So the other components are minor components. These are soluble sugars, less than 2% glucose, sucrose, but these will act as a kickstart for the fermentation process. Non-starch polysaccharides constitute about 3 to 5% in the grain. They have limited fermentability. So they influence the fermentation kinetics. So protein, of course, high protein means that the starch concentration is commensurately lowered. The zein, which is the main protein in maize, which forms matrix around the starch granules. And then when excess protein is there, it will reduce the enzymatic accessibility to starch therein. So optimum ethanol corn protein should be around 8%. Normally corn is around 8 to 8.5% only in terms of protein. So when the protein ends up in the DDGS component, it enhances its feed value as well. That's again one reason. The oil component, of course, oil will not ferment, we all know it, and then it adds value through the oil extraction and biodiesel feedstock it can add. And then excess oil will inhibit the yeast slightly and it will reduce the fermentation efficiency as well. So moderate oil in corn, that is 3 to 4%, which is a normal thing. Around 3.5% is a normal thing that is preferred. Fiber, of course, fiber is cellulose, hemicellulose, and lignin. This is unfermentable. And then in standard dry grind systems, of course, the high fiber will reduce the starch, increases the DDGS bulk. This is the grain solid bulk. And then the breeding target should be for lower pericarp thickness. Of course, it should be optimum because the pericarp becomes too thin, then it increases the popping in the corn kernel, and popping increases grain quality and the ear rods increase. So it should be optimum. So it should not be very thick. That's the inference here. Then the enzymatic accessibility. So here, even with high starch, the ethanol yield from the corn kernels may vary. One is on the starch granule size, the protein encapsulation of the starch granules, what we discussed the previous slides. Then the vitreosity of the endosperm. This is also a key component. So ethanol yield is not only percent starch alone, other components which are adjunct to this, like what we are discussing in the starch granule size, the protein encapsulation, vitreosity of the endosperm is also matters. So in sweet corn, we have no starch. These are only the water-soluble polysaccharides, which are facilitated through the mutants like Shrunken 1 and 2. Then the waxy corn, it's WX1, which enhances, the branching and all those things. So our main topic is not specialty corn, but essentially there are modifiers in the corn endosperm and kernel which will impact the different components, particularly the starch and protein. That's the intention. Then the ethanol yield marks, roughly 1 ton of maize gives about 400 liters of ethanol. And if we increase the starch by 1%, we can gain ethanol by about 1.5 to 2%. And if the kernels are a bit soft, then they may improve the yield by about 5 to 7 liters per ton of corn. So ideal ethanol corn grain profile should have around 68 to 70% starch, amylopectin around 72%, protein 8 to 9%, soft to semi-dense endosperm, then the low fiber pericarp, then kernel size uniformity is always desirable. So some of the industry personals have given their say. They have given the comments like driving the rural economy while sustaining the environment through ethanol extraction from corn. Then some other components like the ethanol blended program is definitely entailing a shift from sugarcane to maize-based ethanol. So this was about ethanol. And then the second component of my talk is about the high starch maize hybrids or cultivar. So, this is in the context of overall improvement in maize yield and quality. We have over, about 12.5 million hectares of corn, and then close to about 50 million tons of corn. Recently, we have seen 55 million tons of corn is being produced. That's the focus area. And IMR is a key driver of that particular process. And herein, we need to harness the partnerships and bridge the industry grower gap. That is the intention. So why does high starch matters? We already seen the components. There is rapid growth in the industries, particularly the poultry is growing at double digits, 10 to 12% growth. Then demand for wet milling, ethanol demand is increasing. And the starch concentration affects the processing efficiencies and the margins. And we have an opportunity to align the breeding goals with industrial value chains now. Because as of now, there is no premium for the value-added high starch or high oil corn. But if it is given, then there will be incentive for corn cultivars with high starch, high oil, etc. to be grown. So we know that feed and poultry constitutes about 65% of the total production utilization. Then industrial needs are around 20 to 25%. Food and all constitute about 15%. And by high starch, we mean higher endosperm with about 70% or more starch, optimized amylose-amylopectin ratios, then the lower protein oil trade-offs acceptable for the processors. So as the researchers, we need to increase the corn availability, that is by giving high yielding corn hybrids, increasing the per unit productivity. Say, for example, post-rainy corn gives about more than 5.5 tons per hectare yield, touching up to 8 tons as well. And then spring corn also is commensurate with post-rainy corn, rabi corn, but it has per day productivity advantage compared to post-rainy corn of 145 to 160 day duration. Spring corn is only about 95 to 100 day duration. So we can increase the per day productivity there. And then that is harvest index also is higher in case of the spring corn and post-rainy corn. And of course, the quality improvement for high starch and high quality DGS derived corn also is good. So we already discussed about the endosperm, constituting about 80% of the total corn grain, and then the components of starch, feed, ethanol readiness, and the other products which come from there. We already discussed with these aspects. I will not dwell deep again. Flint corn, of course, is very vitreous corn, which has got a hard crown and region. And then semi-dent corn has small dent therein, and dent corn, has a big dent in the crown region of the corn kernel. And the dent corn is ideal, but dent corn, mostly it is temperate corn, but India grows less of temperate corn, and we grow temp drop corn, which is semi-dent corn mostly. But it is also good for improved starch release and best ethanol recovery as well. Whereas flint corn purely has a strong protein starch matrix, what we discussed earlier as the proteins forming, encapsulating the starch granules, and therein lower starch accessibility is there. So easier the extraction of starch from the grain, better it is for the processors, and they like that sort of a grain. Then what is the genetic basis of starch accumulation? So we know that endosperm development and the carbohydrate partitioning are key. In case of tropical corn, the harvest index is around 25 to 26%. In case of temperate corn, it is about 45% harvest index. So therein the partitioning of carbohydrates is facilitating the grain in more of temp drop type of germplasm. Then we know there are several starch pathway influencing the starch, AGPase, SS, SB pathways, and then there are several modifier genes which impact the starch synthesis and ease of extraction. And then genetic background is a very big factor in case of how much of starch comes. As we said, temperate or dent corn has much more access for and ease of starch extraction. So the core trade-offs is that negative to weak correlations are there in several germplasm pools between yield and starch. So high starch is linked with softer endosperm, and we need to select for both per kernel starch and overall, because ultimately farmers get price for their yield and not for the starch. Then breeding approaches used, we can do phenotypic selection for kernel traits, and recurrent selection within elite pools can enhance the starch component, and then hybrid testing with industry relevant quality assays, because I may project one particular starch assay done by a particular method, but then the other components, other methodologies may be used for assessment of starch. There will be a variation of significant variation in terms of the starch recovery therein. So, for example, if we have hybrids with 70% starch and a yield of about 8 to 9 tons, which is what post-rainy corn or rabi corn gets in. So we can have improved starch hybrids with about 72 to 74% starch, and then we can have processors gaining 3 to 5% more in terms of starch therein. So what are the environmental effects? So high temperatures means slightly lower starch recovery. Then nitrogen management, the fertilizer dose what we put, it also alters the protein starch balance. There are huge G/E interactions. As we said, Kharif maize, lower recovery, Rabi maize have favorable G/E interactions because continuous sunlight availability and warmer days and cooler nights enhance the starch accumulation. Then when we come to the seed industry role is particularly with regard to making the hybrid seed available with both yield and starch of hybrids, integration with the processors for the trade, what they require. Example, oil industry, corn oil, they will want endosperm with embryo with a higher oil recovery. Starch industry would want better endosperm starch recovery. Then the storability of that and the contract production models can be assessed, that is assured buyback models, which will enhance the freedom to operate for both the industries and also the buyback guarantee for the growers as well. The phenotyping bottlenecks are wet chemistry is accurate, but it is slow. We all are knowing that NIR calibration is not much in use, but then for Indian germplasm, there are calibration gaps, what we have seen, and there is need for standardized protocols across the programs. And from a processor perspective, higher starch is what they need if they are looking for starch as a output, and they need higher throughput and lower energy cost to recover that starch. Consistency is more important than what highest value we get, and there should be a long-term sustainable hybrid partnerships there between the processors and the industry and the growers. So we know that in Kottava, we have done some assays with regard to our hybrids. You can see that the rainy yields, for instance, are lower, around 7 tons at most under favorable conditions. And then for the post-rainy yields, you can very well see that they are hovering around 11 to 13 tons per hectare. And then the spring yields are around 11 tons per hectare. Then when we go for the key components for enhancing productivity, one is the quality seed, other one is optimum plant density. Say, for example, we need about 32,000 plants per acre, that is about 80,000 plants per hectare in case of the Rabi season, and in rainy season, at least 75,000 plants per hectare will be a good driver for driving the production and producibility. Then mechanization is increasing because labor availability across regions is decreasing. So we need to go in for pneumatic planters and the interculture experiments through mechanization, because you know that timely weed control is very key aspect of corn agronomy. And then we need in India, we have not solo corn, but intercropping systems as well. We need varieties or hybrids amenable to that. And we also need, with the El Nino staring upon us, we need not only hybrids which are high yielding, but should also be climate resilient with a good root system, with a good, strong agronomic aspects, and then higher harvest index relative to what we have previously. So here you see that overall in our hybrids from Kottava, we have, in Kharif around 70% starch recovery. And then in Rabi corn, we have seen that it's about 80% starch recovery is there. That's the main component of that. So if we are able to increase the starch content by 3%, then as I said, 3 liters ethanol per ton of maize can be enhanced. And if we increase 3% starch, it will also lead to extraction of 25 to 30 kg more starch per ton. So that is the premise on which we need to proceed with regard to breeding. Then we need to, as government has already proposed, E30 blending by 2030. So as of now, procurement is not based on quality. We can go in for a quality-based procurement price as a policy incentive. Of course, this policy is more at the government level. And then industry also has to support that. Then with regard to increasing the yield and the starch and ethanol favorable components, we need to go in for marker-resisted breeding and genomic selection towards these traits can be a big push in enhancing them. There should be a consortium of public-private sectors, and then a region-specific, climate resilient as also region-specific adaptable, AOA adaptable hybrids need to be there. And then we need to have the wherewithal to meet the deployment challenges, balancing the farmer yield expectation with the processor quality needs. Because farmer always will push for higher yield, higher income, processor will push for higher quality, and a premium price needs to be given therein. So we need to have a setup or a plan, roadmap for defining the starch target for each segment, invest in the phenotyping and data sharing across public-private sectors, and then do several pilots so that we assure both the industry level people and also the growers for that optimum synchronized market linkage. So what we have seen, Kottava has done several initiatives with regard to farmers, whether it is for the ethanol or for silage or for mechanization practices. So they are in place in our system. So essentially, we need to bridge the gap between industry and growers, and seed companies can be one of the sources, and institutions like IIMR, SAUs, and IMDA can be good leads in bridging this gap. And we all know that for us, farmers are as important, but for the value chain of starch and industry to grow, we need a strong linkage with the seed industry, the procurement agencies, the aggregators, and the processors. And we can also, I'll skip these slides in the interest of time, but what my thing is this one. If we are able to give a 300 rupees per ton incentive to the farmer for high starch maize, it will add less than 2% to the ethanol production cost, but it will firmly boost the grower to go in for such hybrids, and it will accelerate the adoption of such hybrids for growing by the farmers. So the takeaways would be that the quality traits, particularly starch, is as important for yield, particularly in the industrial context. A modest increase in premium can align this chain of farmers, processors, and the researchers. Then, as I said, ethanol, if incentive is given on the yield to the farmers, it will be less than 2% of the cost of ethanol, but it will assure the constant supply of maize grain. Then we can do a pilots in terms of contract farming, and intellectual property protected maize models will also accelerate the adoption. This is the buyback guarantee literally by the industries. Then policy support definitely is crucial to recognize these quality traits beyond the varietal improvement as such. And this is a repetition of that. And I would say that all this has been discussed. So this is what a holistic 360-degree approach would look like. One is the end-to-end agronomic services to the farmers. We know several areas have lower productivity. We can bridge the gap by better extension services, advisories to the farmers, and support services through mechanization, usage of drones, UAVs, etc., and combine harvesting to reduce the time between harvest and the industry plateau. So, in conclusion, I would like to say that in Indian conditions, high starch maize is technically feasible. We can manage the trade-offs through focused breeding for enhanced starch, and then there should be a good alignment and synchrony across the value chain, different stakeholders. And the incentive to farmers should be there for them to adapt growing the starch amenable hybrids of corn or varieties. And seed company and seed industry definitely will play its role. And the partners have to pitch in a consonant manner to take this forward to the next level. So I think these were the slides what I had to present to our audience. So I will now open up for any questions what we have.
देव सर आपका कोई कमेंट सर?
Yeah, sir, absolutely fascinating as usual from Venkatesh sir in maize. Sir, I have one point. We in under Kashmir, which is, I believe, the only typical temperate ecology we have in the country. Sir, of late, we have had some European materials in dent and some composites also. Then we switched over to some dent hybrids also, sir. We have had some work done with IIMR, but we found very narrow range in terms of the starch recovery between a perfectly dent hybrid, a semi-dent, and a flint one, sir. We didn't find appreciable variations in the recoveries finally, because as you know, sir, 65% is a benchmark. Extractable starch, I am speaking. Could you please guide us, sir, how to diversify this germplasm program at national level with focus on temperate?
Yeah, basically, I'm telling from the experience on the spring corn, for instance, because spring corn
it is damp drop. It is damp drop.
Yes. As I said, when the topical germplasm is introgressed with temperate corn, what is the proportion of temperate corn to the tropical corn? That is very important. Say, for example, in case of spring corn, we normally have about 60% of the temperate maize and 40% of the tropical corn, because we need the heat tolerance, etc., coming from the tropical regions. The heat tolerance has to come from there, and agronomic features which adapt to our conditions should come from there. Because the main difference between the temperate maize of Western world, USA for example, US corn belt, and our temperate maize is the disease factor and the heat factor what we have. So what we need to address is that the disease factor has to be, we give hybrids which are 11 tons yielding, but then they are susceptible to stalk rods or ear rods, then that is not going to make the day for us. So there should be a judicious mix. In my opinion, the mix can be 60-40, 60 temperate, 40 tropical, but then that would again give more disease pressure to us. And then when we see that, ideal would be 25% of trop and 75% of temp. So
Sir,
that
I'm
is
talking
ideal mix.
mostly in case of the rainy one, because that is our dominating season.
Yeah,
So
rainy corn
25-75 will
definitely.
be an ideal scenario. Yes.
Yes. So in that there also, what I'm saying is that if we go for a 25-75 scenario, I mean to say 25 temperate and 75, still the disease pressure is higher even in that scenario. So something like a 60-40 mix would be ideal, but then we need to do some background selection, some recurrent selection within the heterotic pools in order to remove the deleterious recessive alleles and then increase the yield component of that. Because ultimately what happens is that when you are going for hybrid breeding, per se parent producibility is a key component. As we increase the temperate component, the disease component is going to be behind us. And as we increase the tropical component, the yield component is going to be taking a weight. So we have to do a tight rope walk between, as you said, 75-25 temperate tropical to, a sort of a 60-40 type of a
60-40
temperate
balance in place
tropical.
of tropical
Yes.
temperate. Yes.
Yes.
Because
That
sir,
balance we need
normally
to strike.
when you look
Yes.
at the national program in which we are a part of, we are still not absolutely, I won't say to the level which we desire actually. And 65% ethanol recovery is still, of all the hybrids that we have screened with industry also, very few come into that bracket. So I think unless we diversify the base with germplasm enhancement, we will not be able to reach to the level as is desired, because the next target is E30 within 5 years, I
Yes.
suppose. Yeah.
So, Zahur, what my suggestion would be that, when we say US corn and their increased inbred yields and the overall hybrid
Sir, I will
yields.
make a request for all the maize program of the country to your good self. Could you share us one slide of the points? Because maybe we may lose it in the discussion. Please, one slide only.
Sure. I can just, after
To
this, I'll
Roman,
send
please,
it
because it will
to
be beneficial to
SL
all the
Yard sir.
program. Yes.
Yeah. I'll send that
What
one.
should
And
be our strategy? Yeah.
Yeah, one thing is, when we see the temperate corn, the inbred enhancement didn't come just like that. They have 15 to 20 cycles of recycling of inbreds. That means initially they went in for the heterotic pools, and then within that they made synthetics with the elite lines, and then those synthetics, the Iowa stiff stock synthetic, it's recycled almost 25 cycles now.
25, yes.
So the point is that the private sector did not completely rely on the Iowa stiff stock synthetic. It made crucial additions of the industry ready inbreds with the Iowa stiff stock synthetic on the female side to increase the standability and to increase the harvest index and to increase the combinability of the inbreds which they derived from that. So in India, in particular, we have not undertaken so many cycles of refinement of our base male and female heterotic groups. So first thing is have a set heterotic group. Second thing is enhance the heterotic pool within the male group and female group. Bring it to a certain level of benchmark, and then what you do is through DH process, accelerate the line derivation, and from these lines you do the hybrid breeding. That will give us both the improved parental producibility and also take the yield level of the hybrids to the next level.
Yeah, that will be so. Sir, please share this one slide for our strategy, please.
Sure,
For
sir.
the national program, please. Dr. Roman, you may
Sure.
come in, please.
sir. अगर
Dr. Sir, one question also from Mr. Mahesh Khatale is what is the relation between high starch versus high ethanol?
See, the point is that, if starch is the main component which leads to ethanol, and then higher the starch, higher the ethanol recovery. This is what is the flow diagram.
Sir, in between, can I ask, the heterotic pattern that we have available in the country is based on LM13 and LM14. As you well know, these are the parents of PMH1. If can we somehow bring in Tuxpino on one side and Suvan one on the other side to diversify both the pools? Because Tuxpino will give us standability and Suvan will give us this downy mildew resistance, if it all still works.
Yeah, see, basically, if we are seeing the Tuxpino, what we get from Mexico, originally Tuxpino was a white endosperm one.
White background,
Then,
yes.
yeah, later on it was converted to yellow, and then yellow variants are available with the most
yellow
of the
is
seed
available,
sector.
sir. Yellow is available.
Yes,
Yellow is available.
and Tuxpino is one of the best combining entities. You know, combining ability means we only say about Tuxpino. And
Sir,
then
our center has worked with Suvan extensively in the last decade, and we have had some success in introducing some Suvan traits into our temperate material.
Yes, but the point is Swan again, when you do inbreeding with Swan, see, because Swan basically you should see that the origin was Swan composite, which was a complex of different germplasm across the world.
Yes, from Thailand.
Yeah, but what happens is what is adapted to the tropics again has a lower harvest index. It doesn't have a high harvest index. So then we have to be careful in the graded introgression of Swan because Swan gives best defensive traits, foliar disease tolerance and the DM tolerance and also the FAW tolerance. But then color also is very good. But then what happens is that it brings down the harvest index as well, Sahur. So the point is that we'll have to balance the harvest index, what we get from Swan, with the temp crop introgression of Tuxpino on the one side to get really high yielding heterotic hybrids.
Sir, that you have to put for us, please, in that slide, please.
Sure.
Thank you. Dr. Roman, please.
Okay, sir. Sir, one more question is there that can Vexicon play important role in ethanol production, sir? That one.
Yeah, I will share one example. Recently, we introduced some of the Vaxi hybrids in India and we compared them with the high yielding normal corn varieties, particularly in spring, because what we imported was from temperate climate. So spring was the maturity which was commensurate to the Vaxi corn. What we see is that Vaxi corn will not give you the comparable yields with the normal corn. This is yield drag will be there. So if at all we need to promote Vaxi corn, then we need to incentivize the farmers by saying that we will pay this much more for per ton, so that they are able to grow for it. And other thing is the disease component. Vaxi corn from the temperate climes will have higher disease susceptibility. Spring corn is still okay because fewer diseases are there. But if we take it to a large scale in rainy corn and to the late Rabi corn, there may be issues of stalk rots in particular, which we have to face. And in rainy, foliar diseases also will be there.
Sir, thank you so much, sir. So many emojis we have come up, and from the chat we can know that your presentation was excellent, sir. And everybody is appreciating your presentation, sir. And thank you, sir.
By Menak Roy.
Sir, one last question, sir. That Menak Roy, you can ask.
Hi. Have the question that you have mentioned the oil content 10 to 12% oil plus enzyme. So generally the corn contains the 3.5% oil. So can you?
Yes. Yeah, oil is 3 to 3.5% only I have mentioned. Protein is what I mentioned can go up to 9%. So generally it is 8% in corn. So the point is that oil, see, there is something other thing called high oil corn, where the oil content can be as high as 15% and 25%. And then that comes from the exploitation of xenia effect. We have high oil varieties as pollinators, and then there are certain amenable female counterparts. So therein what happens, because of the xenia effect of pollen on the maternal tissues, the embryo gets higher oil extraction. That is high oil corn in particular. But for starch and all, high oil we are not focusing on. That is only for corn oil extraction, if I can clarify.
So I'm taking context for this corn oil separation because we are exploring the technology for the corn oil separation before the dryer. So if I process the high corn oil contains maize, is it possible? Is it possible in India?
One major point is that, about 20 years back only, DMR has some publications with regard to the high oil corn. But the point is that as long as the incentive is not there to the grower for high oil corn, he will be paid only on the basis of yield. So he will not be paid a premium because he's growing high oil corn. Though high oil corn will have a yield compensation of easily about 10 to 15% lower yield than what normal corn gives. So one thing is incentivizing the farmers. So that not being the case as a policy support as on date. So even worldwide also, nowhere has been an incentive given for growing value-added corn. That is why the multinational companies in general are keeping away from breeding for specialty corn, like high oil corn or QPM, high endosperm QPM, etc. Because the yield compensation ultimately will not be incentivized through higher procurement price or higher buyback rates to the farmers. Second thing is what 3 to 3.5% oil is there in the current corn hybrids. If at all we set up an industry, that also should be viable. Should we have a systematic streamlined processing chain where from the endosperm we get starch and then we get the oil and the feed cakes from the germ. So we know that, when we have such a separation and then use endosperm for starch extraction and then hydrolysis of starch to get, ethanol, the other components, what can come from the starch. Oil has to be treated separately as a byproduct. And from that, if oil industry is set up, then I think that both starch industrially and also the oil, edible oil from therein, that will make sense rather than going for oil alone.
Agreed. Is there any species of the corn which can give the higher corn oil, even 6%, 5%?
So what I am saying, sir, is that in case of corn, there is a phenomena called xenia. अगर आप normal corn भी ले लोगे and if you are pollinating it with the high oil males which are available, then what happens because of xenia effect, even this normal corn with 3 to 3.5% oil will give about 5% oil in its embryo. That can be taken out and then that can be processed and then you can increase the oil extraction, edible oil extraction, what cornola and all are there.
Dear,
But then
we have some, if any colleague in this forum wishes for some lines which have high oil, you can get in touch with our Hyderabad center with Dr. Sunil. We have lines which can be shared across.
Okay,
Okay.
sir. Thank you so much, sir. Because we have another session, sir, we have to move forward. Thank you so much, sir, for your excellent presentation, sir. And Subhi madam, our next presentation, Subhi madam hai kya? आगे.
Hello,
Yeah, she's there.
She's there. Thank you so much. Okay, ma'am.
good evening, everyone.
Madam, may I introduce you to? Thank you.
Okay, sure. Thank you.
Okay. So I would like to introduce to our next expert speaker, Dr. Subhi SB, Senior Scientist Agriculture and Entomology at the ICAR-IIMR. She is currently posted at Delhi unit, which is in Pusa campus. Dr. Subhi is a leading maize entomologist with expert in integrated pest management, plant host resistance, and management of invasive pests, particularly the fall armyworm. We all know about the fall armyworm. And her research has made significant contribution to sustainable maize protection. Madam, your talk on integrated pest management for sustainable and resilient maize production system will provide valuable insight into effective and eco-friendly pest management strategies. So may I now request Dr. Subhi SB to kindly deliver your lecture. Madam, please.
Thank you, Roman, and good evening, everyone. Are you able to see my slide? Hello?
Yes, ma'am.
Yes, ma'am. Is it moving?
Yes, moving.
Yes, ma'am.
Okay. Yeah. So it's about integrated pest management, but agro-ecosystem analysis is the one. It is a primary step because we were listening to Dr. Venkatesh and he was talking about the temperate germplasm, tropical temp trop germplasm, and where we have to balance between the disease and the yield and many things. So we will see where the pest problem comes, when it comes, and where the disease issue comes. And mainly, I'll be talking about the insect pest only. For the insect pest, in an agro-ecosystem scenario, for a pest, when we do the monocropping, it is deviating from the natural ecosystem. So whatever is beyond the balance. So something will be coming to attack it and reduce its population. So these are the pests, and who is counteracting that? It is the natural enemies, which you can see in the bottom panel. But in the case of annual crop, you know that the biocontrol work well in the case of tree crops. But in the annual crop, it is an extreme scenario of agro-ecosystem. We will be cutting the crop in 3 to 4 months. So before the natural enemy comes in, the pest comes and multiplies. So the most important pest in maize, pest is something out of place. So it is the weed, and which can cause yield loss up to 50%, because maize is a grass in the early stage. All the shallow root ones compete with the maize. So when we will be able to achieve the weed control, and half of the crop protection is over. And also, so we have very good weed control agents, pre-emergence and post-emergence weedicide, and which are agronomists who would be talking. So now we have been grappling with this issue since 2018. This fall armyworm arrived, especially in the case of late Kharif planted crop and late Rabi planted crop. And it get late Kharif planted crop in all over India. It is a major issue, and it is a late Rabi planted crop. It is an issue in the peninsular India, and late spring planted crop in the case of northeastern India. So it's all about agro-ecosystem. So here, this picture is from my field in 2022 August. So it is a late Kharif planted crop, and you can see how the crop has suffered from fall armyworm. It caused 100% infestation, but it do not kill the plant. So then in the same year, we went for monitoring. This you can see in Assam. Assam has a very different issue. You can see 2022 August how it is in Delhi, because Delhi is a semi-arid tropics with hot, warm temperatures. And when you go to Assam, they have a different issue. And also in Manipur, in Assam, it is a low-lying area. There they suffered the banded leaf and sheath blight, but in Manipur, it is tertium leaf blight. So Dr. Sahur was talking, and there also it is a hill environment where it is a slightly warm in the day, night, and extremely cool temperature with high humidity, which will cause the flaring up of the TLB. So the major insect, insect pests are prominent where we get the intermittent rainfall, like we can say like a beach Caribbean sort of climate, where you get the intermittent rain with a good sunshine, and it comes. So in India, the earlier, before the invasion of fall armyworm, Chylopatulus in the Kharif maize, and this sesame inferens, the pink stem borer in the spring maize, and the shoot fly, and this Sesamia inferens in the Rabi, and also the late spring is an issue. Then the shoot fly comes when we sow the spring maize after 14th of the first fortnight of February in the northwestern India, Punjab, Haryana, in Punjab, Haryana, Delhi, Western UP. There it can cause, it infects 100% of the crop. And if you don't treat the seeds, it can cause more than 50% yield loss. So the seed treatment is a sole option for shoot flies. It won't come in peninsular India, but in peninsular India, it comes in sorghum, and the species which comes in, the shoot fly species comes in northwest India is Atherigona nakvi, but in sorghum mainly it is Atherigona succata. So that's why I told, because you must be wondering why it is only an issue in the northwestern India. So in the Kharif maize, that spotted stem borer symptom is very much easily identifiable. It feeds in the world for a while, and it goes to the stem or from up, then it will die and the plant world will die. So you can see that initially only 5 to 10% of the plants die because of that. It is a major issue still in Punjab, Haryana, if your Kharif sowing is early, and also in southern part of India. Actually, Caelopatilus come in hotter climate when the rain is low. And the pink stem borer comes in Rabi, and pink stem borer symptom is mostly not noticeable because they usually lay eggs very close to the ground near the leaf sheath. It hide the eggs in the leaf sheath, so they hatch up so many larvae. Like you can see the first in the bottom panel, the first picture, so many feeds together, and when they so the plant when the world dry up, then only we notice them. So this is only for an academic purpose, how the egg lay, where the egg lays, why pink stem borer is pink and spotted stem borer is spotted, you can see. So this is the typical symptom of spotted stem borer. See the spotted stem borer early symptom is somewhat similar to the early symptom of fall armyworm. So it is a typical confusing things, but can you see the powdery material, very fine powdery material, and the small holes. If you see, it is a spotted stem borer, and it won't cause the bigger holes like in small fall armyworm. Why? Because when the larvae, as they grow, they won't be feeding in the plant world. They break the they bore from down. You can see it mostly it attack the second above ground internode and it bore upwards, and so many parasitoids. So in this particular picture, you can see both the symptom. Why it is a stem borer? So you can see the world, it has a symptom very similar to fall armyworm attack, but the plant remains stunted. You won't see the world cut. In the case of fall armyworm, it can cut the world. So it is a pink stem borer. Pink stem borer is much more sturdy. If it comes in, it can even kill the, if you have a soft stalk genotype, it can kill even the entire plant, especially the inbred lines. Some of the inbred lines like BML6 is very susceptible. But after the invasion of fall armyworm, this two pest has become very less. Then the management of the stem borers. Stem borers in the previous slide we saw, they come and first they lay eggs in only a few plants. So that plant is the home plant of that particular egg mass. Most of the insect will be staying there, and some some caterpillar, they will be spreading to the nearby plants. So see, when the home plant dies, so it don't have any much space to feed, so it will migrate to the nearby plant. So you can see this nearby plant. It has a slight wilting symptom in the world, as if it has not got any water. It is because the bigger caterpillar, it made a hole in the second above ground internode, and it is going and it is boring up. So the pest management. So in this stage, if we are able to diagnose, we just have to remove that dead plants, bury them or burn them, and we can put the Fertera granules are very common. We use in sugarcane pest management. Also, we use in the paddy pest management. So it is a chlorantraniliprole 4% GR. We can simply put in the world. And if there is more than 10% if you are seeing, then we can spray. But nowadays, it is very much restricted because of the fall armyworm. It is ruling for the past 6 years. So, but that scenario can change. That's how the adaptation and that competition lead to selection. But in near future, it is it's not seem that it will be one minute. So in near future, this fall armyworm is going to roost. Shoot fly is a pest which comes in the spring maize. It comes when the plants, as soon as soon after the germination it comes. It lays eggs near the base, also in the sheath and in the leaf, and it kills the plant if you don't treat the seed, it will kill the plant within a week. So it is also causing a dead heart. But you can see this twisted kind of a plant in the leftmost panel. It is a treated plant. Because of the treatment, even though the shoot fly came, the plant could survive. So the imidacloprid is 600 Fs. It is a very good seed treatment molecule for the treatment when you sow in the spring maize. So we have to complete the sowing by the first fortnight of February, because the maximum attack happened up to second fortnight of February to first fortnight of March. Then comes the fall armyworm, but there are still the people confuse it with the other pest. You can see the first panel. See how it is, how the fall armyworm damage differentiate, how we can distinguish from the other damage symptom, even though the caterpillar look the same. So you can see that in this in the first panel, that caterpillar has feed from the middle from the whorl, from the whorl leaf, and in the second panel from the margin, and in the third panel the complete leaves has been stripped away. It is caused by 3 different pests. The first, it is by the fall armyworm. Fall armyworm is distinguished by the white Y-shaped marking in its head, this helmet-like part you can see. In the second panel, you see it has eaten from the margin, but the caterpillar look almost similar to fall armyworm, same size and same feeding habit. But see the head, it is very much important, because every year in this time we get the pictures from particularly the Jammu and Uttarakhand. Is it fall armyworm? But it is not fall armyworm. It is Mithimna. Mithimna is the second best. There are 2 species of Mithimna. Mithimna laurei, which comes in wheat also, and Mithimna separata, which comes when the temperatures are a bit warm. And in the third panel it is grasshopper. It is very, very much common around in the August, September. It is very much prevalent in Maharashtra, Madhya Pradesh. After the rain, they strip away the crop and fly to another field. So can you distinguish from this picture? Everybody said it is fall armyworm. We need a immediate control measure, but it is not fall armyworm. It is Mithimna separata. This is from Jammu. This picture is from Jammu. So this also, the same control measures can be adopted, but we need not to panic. It is more of a localized phenomena. In some part of the country, it comes. So the agro-ecosystem analysis is very, very much important. Before the inversion of fall armyworm, the farmer goes to the maize plant, and after the basal application, the first fertilizer application, they go to the plant. But when the fall armyworm invaded, that the farmers panicked, and some of the farmers in the first time when they saw, they even raised their crop to the ground. They destroy their crops. But that is not then necessary. It is a very easy to control if we identify the symptom from the early stage. So the basic thing is that don't allow your pest to cross a certain limit, which causes the economic loss. So most of the approaches, we take a 10% of the 10% of the infestation. We ask the farmers to spray, and it is weekly scouting is necessary. After that can be started around 10 days after germination of the crop, especially in the late planted crop. You don't have to worry about the fall armyworm in the spring planted maize if you are in the northwestern India, especially in Punjab and Haryana, but you have to worry late in eastern UP. Also, you have to worry in Bihar. And if it is in Nagaland, Manipur, Meghalaya, in April itself, you will get a very high attack of fall armyworm. So yeah, it is about the season in various parts. So this main picture, you can see we were called upon to check the infestation, but it was a pre-flowering stage crop, and it was badly damaged by Chilopartulus. We could not see fall armyworm. It was in Manipur in 2019, but in early planted crop, yes, we could see the fall armyworm attack. In the late planted maize, about 6 to 7 leaf stage we could see, but this pre-flowering crop was attacked by the Chilopartulus. So there are many pests, and they find their own niche. They don't compete. They find their own niche. So that's why if you see a fall armyworm, only fall armyworm, 95% of the maize is attacked by fall armyworm. Then if it is Chilopartulus, the fall armyworm, if it attack early, the infestation of fall armyworm will be less because they avoid competition. So to have a good plant protection, the basic step is good nutrition and irrigation. The fall armyworm comes in with all the pest infestations start from second leaf stage to 7-8 leaf stage. They become a major issue in the sunny part of the India. So there it is better we give the end split. In maximum split, if you can give, that would be a better option, because immediately after the spraying, if you give an end split, that will help the plant to compensate faster. Then the fall armyworm is an invasive pest and is a strong flyer. That's why even if you don't see in some part in the spring and in the winter, it dies off, but immediately we get the rain, it comes, it flies and comes. And another thing is that why we are not getting in the winter season, particularly where we get very when the temperature goes down. It is not an issue in Srinagar and in high altitude of Himachal and Uttarakhand, but it is an issue in Jammu and Punjab, where the temperature is moderate, because they cannot tolerate the low temperature, also the high temperature. That's why we are getting them in the Kharif season. So it is from a remote the dirtland hill of Mizoram. You can see it is a June land. The farmers, they planted a hill type of planting. They practice 3-4 seeds in one pit. So there it is an excellent breeding ground for the fall armyworm. You see how the crop is damaged, because the farmers never got an issue in maize earlier. They got, yes, stem borer attack was there, but only 5%, 10%, and never sprayed anything. So when this pest came, IMR got a call, we went and we saw this condition. So this maize did not, it is a traditional variety they maintain, a population kind of thing. So they have not got any yield from this crop. Then how we can monitor the arrival of the fall armyworm? Earlier we recommended to go for the pheromone track monitoring, but our observation revealed that the fall armyworms comes first. You are getting symptoms in the field, then only you are getting it in the trap. But this trap monitoring can help us the next step. Suppose if a male is trapped, you will be having at least one female in the field, and she will be laying around 1000 eggs, 1500 eggs minimum. So that's why this pheromone trap monitoring is an integral part, and that if you need not put 4 trap in every acre, and nowadays we go for FPO. So you can put even if you have some 50 acres of land, you can put it in any of the field where the first planting has happened. So where the first germination has happened, there the fall armyworm is ought to come. And one more thing, in the spring season, in the early spring and in the early Rabi season, you may get another pest also trapped in the trap. It is Mithimna lorei. In this case, you may get a lot of Mithimna lorei, especially your area is known for wheat. And if you have the both maize and wheat, you will get a lot of Mithimna lorei, but it is not that issue in the maize. So this is we have been monitoring fall armyworm since 2019. And this regular monitoring you can see. So maximum highest intensity we are getting in Pantnagar, then Delhi, Udaipur. In the northwestern India, it is maximum. And in the southern India, it is almost balanced. So it is how in every plant, this is in 2020. The fall armyworm came in 19. I first saw in my field in 19. Then in 20, almost every plant was laden with egg, and in the initial stage, when the plant is around 2 to 3 leaf stage, it lays eggs in the lower leaves. And then as the plant grows, it lays in both upper and lower leaves. See, first it is laying this particular egg patch contain around 80 eggs. So see, and in among these 80 eggs, when they hatch out in a group, the wind will carry. They produce a balloon. It is called ballooning, like a silken. This caterpillar produces silken thread. They spread to the nearby plants. That's why in the initial infestation, you will see only 5 to 10% of the plant, but within a week, your entire field will be infested by the fall armyworm. In these 80 eggs, only 6-7 will feed in the world, then other will distribute it to the other plant. This make the fall armyworm a most destructive in these years. So we ask the farmers to monitor from the early stage. When we see this papery window-like symptom means they are very early stage, and in that even the mild pesticide can work. And the farmers can record the infestation intensity from 3-4 points in the field. If it crosses 10%, if it is about 10%, definitely we need to spray. If we don't spray and see this first leaf, it has caused only small scrapping because the insects they are very small. So we have to adopt control measures in this stage. And if it is not, and within a week, it will cut the entire world. So what we have to, if we don't adopt, even if the infestation is low, in UP by April, the crop will be around 7 to 8 leaf stage, and you will see only a few plants are infested with this fall armyworm, and within a week, and the nearby area, and it will move from UP to the adjacent area. If the planting continues, that areas will be infested with the next generation fall armyworm in a very large number. And if you don't apply control measures, and it can go into the ear of the plant, and the symptom progression, it goes like this. We have to adopt control measures in the early stage because they within 10 days, the entire world will be gone sometime. So the biopesticide can work in the early stage, and among biopesticide, whatever we have tested, entomopathogenic nematode EPN Heterorhabditis indica strain is the most fastest killing one. Even though we recommend BT, Metarrhizium, Anisoplia, and many fungus we are recommending, but EPN is the fastest killer. If your formulation is good, if you sourced it from a very good company, it can work well. But the temperature in the cooler areas, it can work. And the efficacy of EPN in higher temperature zones of northwestern India, it is still not there. And this biopesticide like fungus and all, they work very good in the northeastern hills, also in moderate climate conditions of the southern India. But in northwestern India, they spread very fast, and the degree days are the day length is longer. The plant is growing fast, so the insect is growing fast. The spread is faster. So we need to apply pesticide. It is option. And in the late Kharif planted crops, Spinotoram is the one which give a longer control. Earlier, we used to recommend imamectin benzoate because based on the laboratory assays, the fastest killing one is imamectin benzoate. But so what is happening in the field? Imamectin benzoate is the one which is used for vegetable crops also. Because of it is shortest harvest interval because the compound degrade very faster. So what happens when the plant is free of the pest caterpillar, the moth is coming and laying eggs in the fresh plant. So that's why we got complaints from many farmers. Imamectin benzoate is increasing pest load. It is the because of the efficacy of the imamectin benzoate, the plant is becoming fresh and we are getting more eggs. So imamectin benzoate can work when your pest load is low and if we are towards the winter. But when we are in the Kharif season, late Kharif, when the temperatures are warmer, you are expected more Folamivum. The Spinotoram has a longest residual action. It will work well. Then chlorantraniliprole, broflanilide, many pesticide has been recommended by CABRC. We know that in the group contain input day distribution agents also. Don't recommend any old pesticides because this Folamivum. We know that all these pesticides were originated, worked upon, and synthesized, tested, and these pesticides are very much part of the agriculture in the Western world, particularly the US. Folamivum has been a pest there. Yeah, still it is there, and it has acquired resistance against the traditional pesticide, OP pesticide, and carbamate. Don't recommend cypermethrin. Don't recommend profenophos. Recommend only the new molecule, what is prescribed by the CIBRC. And in our own study indicated that in Indian population, we got the 2 resistance mutation, actually 3 resistance mutation in the acetylcholinesterase gene, which is responsible for the knockdown action of the pyrethroids and the other OP, not carbamates. And were there, and if the insect carried those mutations in India, and 2 of those mutations we saw in Indian population, also it has been reported in China and other Asian populations. So don't recommend the older pesticide. Also, we have to go for the to have a sustainability. We have to go for pesticide rotation, because whatever you feed continuously, it is going to acquire resistance. So we have to change tactics. And we can even go for the poison baiting, but it is a tedious one. And in the pre-tag, yeah, it can go in the ear, but the ear is an issue in sweet corn, also in the seed production plot, because many of our inbreds are inherently tolerant and because of good number of husk and the husk coverage. But this inbred lines, they are weak and they are easily penetrated by the Folamivum. So we can give a pre-tasseling stage spray. We can use the drone. When we use the traditional formulations, actually it is the future is the era of the drone spraying, because we get an issue in spraying in tall crops like maize and sugarcane. So the farmers are increasingly resorting into drones, but we should develop drone amenable formulation, ULB kind of formulation, ultra low volume kind of formulation we use, but we have to use or else now whatever formulation is recommended, if you use, don't go for the per liter spray volume, but you go for the per acre spray volume. Calculate the area accordingly. Suppose if your drone require only 25 liters of water per acre, and the 100 ml of Spinotoram is required, you put all 100 ml into the entire acre. So that's how it works. But the traditional formulation, a lot of pesticide drift will be there. So that we have to think of developing ULVs. So it is not an issue in traditional baby corn cultivation, because after, when the whorl structure is gone, it will go to the flower. When the flower open, it will go to the baby corn. But in the case of traditional, we remove it before they opens. And so the insect is also removed. You can see in this picture, the flag leaf, it is fully damaged, and all tassel, they had the fall armyworm, but we are removing them. So it is not an issue in baby corn. Don't spray in the baby corn. But if you spray for sweet corn, you may need a spray, but you have to give a minimum 20 days of waiting period. And also the parental lines of the hybrids. And yes, and there is a some of the lines they do good, and some of the lines they are very much susceptible. These lines in the picture, you can see the first is HK1105, and even if you spray or not, it is not much damaged by the fall armyworm. Second, you can see HK161, a line, and the CM212. Both lines are used in a public sector breeding program. And when we spray, yes, you get a very good crop, but when we don't spray, how the crop look like? So yes, ear damage is also very much important. Yeah, so we have been trying to develop a drone-delivered novel oil dispersion formulation. With the help of IARI, we found the dose, how the imamectin benzoate and chlorantraniliprole can be combined. Because imamectin benzoate is a quick killer, and chlorantraniliprole gives a good residual action. So it is an oil dispersion-based formulation. See, the plant it is a sweet corn crop. So we we sprayed it in the flowering stage. But it is when we spray it in the flowering stage, many things we have to take care. It can be toxic to honeybees, so the time we have to adjust. Then what work in the ear damage stage? Other than the chemical pesticide, the one which work well is entomopathogenic nematodes. We have to spray directly to the corn ears with the high volume sprayers. And among all biopesticide tested, EPN is the one which is killing the pest very fast. And also, this biocontrol agents. And while we were talking about the pesticide, the chlorantraniliprole is a green chemical. Green label chemical means the maximum, the MRL, maximum residue limit, no, that LD50, vertebrate LD50 is more than 5,000 ppm, a milligram per gram body weight. Means when you eat it in a teaspoon of the compound, it may not cause, it may not cause much damage to your body, but we should not do that. So the why it is important to choose the safer, greener compounds, because these birds, when we spray, the insect will they become inactive, they become easy prey for the birds. So in the initial 2 years, imamectin benzoate we used, and in the campus I have seen so many baby crows falling from the tree, dying. They died, and the family members and just thrown them out. And that issue I have seen. So in the future, we have to come up with the safer formulations. And in the chemical pesticide itself, we have safer. What chlorantraniliprole has a very good safety, but at the same time, chlorantraniliprole is an aquatic poison. It is harmful to aquatic insect, but not much harmful to vertebrates. So we have so many other biocontrol agents also, and they work well when our spray is less. So whatever pesticide we spray, they can affect natural enemies also. But we grow corn in an industrial scale. We are getting good prices. Even a 5% loss is a loss. So we have to see where we have to spray. So when the symptom comes in the spring corn, we rarely require, when we go for seed treatment, we rarely require any spray. Also when we are into fodder and silage, no need of any spray. this even fall armyworm is not harmful to animal. Even the birds eat them. They are the food for the birds. So even if it attacked by a in spring maize, yeah, in the kharif maize you may require some spray because it can reduce the foliage. But in spring maize, if you have 10 to 20% fall armyworm damage, you don't have to worry. You just shake off the caterpillar and give it to the cattle, or just straight away you can put it into silage. Then we tell biocontrol egg parasitoids are there. But this is again an agroecological issue because in South, this trichogramma and telenomus work, but in northwestern India, we are getting other parasitoid. If somebody is saying you use trichogramma, it is again agroecosystems, agroecological, geographical area specific. It may not work here. So whatever is working in Karnataka, it may not work in Delhi or in Odisha, but yes, biocontrol play a role. So you can see in 2019 में, this is the 2019 Rabi crop picture, and in 2021 picture. See the world, we have not sprayed anything, but the world is free of pests, and you can see the small pupal cases. These are the pupae of one of the parasitoids. So biocontrol also has a role. When the pest population is low, let it be. The biocontrol agents will take care of it. But when it is a Rabi crop, when your temperatures are low, but when the temperatures are higher in Kharif, don't wait for the pesticide or natural enemies to control. You have to spray the chemical pesticide. So it is just to show that when your pest increase, your natural enemies also will increase. Then when you go for a biocontrol, how you can help the biocontrol agent, it's a common practice in the Southeast Asia to plant the flowering plants in the borders. Also, we can see some of the flowering weeds in the buds can also act as the home for many biocontrol agent. Then in IPM, the important one thing is the early plant vigor, the single cross hybrid we are doing. Then the plant vigor, some of the chemicals, some of the seed treatment molecule containing thiomethoxam, and especially neonicotinoid group, they can increase the plant vigor. The imidacloprid 600 FS, when we use in the spring maize, it increases the plant vigor also. So then the pathology, this you have, then why I have shown this, the spraying method. In the case of weeds and pathogen, we have to use a very shower-like nozzle. But in the case of fall armyworm and other insect pests which feed in the world, deep in the world, we have to use the high volume sprayers which target directly into the world. So these are the, this Starsicum leaf blight comes in the cooler areas. Usually it comes late in the season. Then the Maidis leaf blight comes in hotter areas in Punjab, Haryana, Delhi, Rajasthan. Banded leaf and sheep blight comes in South and Eastern India where the rainfall is higher. So this is the picture we saw in the, so this is the thing which comes in the spring maize in UP. When the soil is heavy, this issue is coming up when we continuously cultivate maize in the same land. This bacterial stalk rot is coming as an issue. Also, Fusarium stalk rot is coming as an issue. So the pathologist, if they are giving the lecture, they may be taking care of it more. And the better thing is that you have to follow the crop rotation. Then this charcoal rot and Fusarium stalk rot again comes where, particularly charcoal rot comes where the temperature is higher and it is drought prone, and Fusarium stalk rot come in the moderate humid condition. So the field sanitation and the clean cultivation, all those crop rotation, all those things can be followed. Then in the case of, then deep ploughing is a practice which will help the soil to open up to predators, sunlight. It will sterilize the soil and it will expose the insect of to the predators. One thing is one stem borer comes in Rabi, one stem borer comes in spring, and one comes in spring and one comes in Kharif. But where they go in the other season, they all hibernate in the stubbles. because one cannot tolerate winter, the other cannot tolerate summer. One comes only in the spring season. The rest of the time, either they thrive in the grasses or they thrive in the stubbles. So this summer ploughing is another thing. Suppose if you are practicing zero tillage, will it increase? But it may increase the disease pressure like BLSB, but it may not increase the insect. In our own study, we found around 13 species of ants which are controlling them. And there are many ground-dwelling predators, spiders, that they hide in the stubbles and they kill them. So it is a plant vigor we have talked about. There are many, CIBRC has recommended, currently we have so many formulations, but this we require. The shoot fly in northwestern India, it is required anyway in the spring planted maize, but in Kharif, in late Kharif, in the other part of India, and early Rabi in the southwestern part of India, like in Maharashtra, Madhya Pradesh, we may require to go for the seed treatment because it can give a good vigor and the insect comes very early. Then the timely sowing is very much important because some farmers sprayed, they did in the early in the season. Very few insect comes in that he has not sprayed anything. The crop is saved, but the next generation will always go to the younger plant. So we have to plant in community level. Then the another is the intercropping. The intercropping in maize, one intercropping is coming up good in the ethanol catchment area. It is a maize sugarcane intercropping. So there we are using the pesticides because the maize and sugarcane harbor almost similar thing. But the actual intercropping for pest management, we have to use the non-host crop. See, sugarcane and maize, they are the similar crop. So there the intercropping effect in the pest will be low. But where the intercropping can manage the pest when we use the non-host crop, it is a leguminous crop, very different volatile profile, because why a mosquito is coming to some person because of their host order. So like that the plant have an order, a typical order. So when we use the non-host crop, maximum the mixing, the maximum masking will be there. So the legumes are very good addition. And some of the intercropping like cucurbits, they can increase the fall armyworm. But yes, you can go for it where the pressure of fall armyworm is less. And this is a norm. This mixed cropping and intercropping is a norm in the homesteads of northeastern India because they know that yes, it is for feed and fodder. I don't have to spray any pesticide, but it is from commercial. It is a soil maize. It is from the same farmer when we visited in Manipur. In 2019, you can see in the intercropped one for the homestead very close to their home. There no fall armyworm attack at all. And in the commercial one, you can see it is full of weeds also. The vacant space is occupied by the weeds also. There is fall armyworm attack. But why in commercial they go? Because the issue with the mechanization and the weed control. So that we have to optimize. So there are many good cropping systems. They work with legumes, maize, groundnut, cowpea, green gram, rice bean, black gram, everything work good. And even the flower crop also. This has a very good demand, especially in the festivals. This marigold is we have not seen any pest eating the foliage of marigold. So it has a nematode repelling property. Not only in maize, it can be intercropped with any other crop which suffer pest issue. So here in the top two panel, you can see the maize is badly stripped away by grasshoppers. And in the same maize field, you can see the grasshoppers are marching and they are just falling into the ditch. Actually, it is one of the control for the locust. You make trenches, fill it with water, they will die. But why they attack the maize? Because they actually feed on grasses. The field bugs, they lay eggs in the in the soft field buns. It is a non-disturbed area in the field. From there, the nymphs emerge. They feed on the grasses. When they get the wings, they fly and move and strip away the bigger grass. Only bigger grass, and with very good foliage is maize. So what we can do is that fill our field buns with some useful, beautiful crops. Thank you so much for your patient listening. Thank you.
थैंक यू मैडम। किसी का सवाल है मैडम से? हेलो।
Yeah.
Roman, there is something in the chat. You can check.
Okay. I love to see so. Focusing, madam. Previous crop model is nature manure for the next crop. Our forefathers of agriculture says it is maize, not good manure for the next crop. It reduces the yield of the next crop. What is your point of view, study and observation? Actually, it is, yeah, maize is a very fertilizer withdrawing crop. So we expect maize to yield a very good crop in a period of 4 months. So from where that corn come? So everything, see, in this earth, whatever matter, whatever molecule, it is one form to another, it is converted. So whatever is it is getting from it is drawing from the soil, it is converting it into the crop. So for the next crop, we have to add that much. So it is a very fertilizer withdrawing crop, but we can enrich this when we put the residue back, also with the interventions like intercropping it with the legume and the other nitrogen fixing crop. We have studied in the long-term conservation agriculture plot for 3 years. We observed, even though the insect attack is higher, it is giving a better yield, because whatever the carbon is only an indication. Whatever the organic matter means, you are putting the sir was saying about the harvest index of maize is 25%. When you get the 25%, you are taken it off. Your 75% is going back to the soil. So what better we can incorporate to the soil? Yes, it has a very high carbon, very fibrous. So how you can increase the N? We can go for the microbiome manure, high N containing things. If you put into the soil back, it can.
अगर किसी और का अगर सवाल है तो बताइए।
Okay, thank you.
Yes.
तो
Yes. Hello.
Hello, sir.
Yes.
Madam, my just one query. So if we go for the single cross hybrid and double cross hybrid in the same ecology. So hello.
Yes, sir.
Yes, Dr. Sunil, please go ahead.
Yes. Suppose a single cross hybrid and double cross hybrid in a same ecology at the same time of sowing window. So is there any difference of attack between this single cross hybrid or to this double cross hybrid by far?
Okay, sir, I think it in a breeder's perspective you are asking, sir. In this in this double cross hybrid, how many so I have to refresh my brain, please.
Dr. Saab, it is as simple as this.
Yeah.
Single crosses are heterozygous cross.
Yes.
Heterozygous, homogeneous, two biparental cross normally.
Yeah.
So you will have two parents. Whereas in case of double cross, it's two hybrids intercross. That means 4 parents.
4 parents.
As you go on increasing the component lines, the resistance will be more. So in case of double cross hybrids, it won't be that much uniform. So every plant, in fact, in a double cross hybrid.
No, Dr. Sir. So I want just that whether such data is some, but whether it is some data is available.
I'm coming there. If you see the fall armyworm spread in Africa, which is the most devastating part where it affects, They mostly on the farmer's field grow three-way crosses. And the
Hmm.
reason is the availability of a substantial amount of variability within the cross itself limits
Yeah.
the flow of fall armyworm as compared to a single cross hybrid, unless you have the parental lines improved for the trait.
Sir, in my opinion, it always depend upon what's in the
Yeah, that's what I
genetic
said. Yes.
background, sir.
Yeah, yes.
So suppose, sir,
Yeah.
I am a combination of my grandparents from both the side. Better gene I accumulate for armyworm resistance, better I'll be able to. Sir, most of the hybrids what we are getting, it is
Yeah.
we are they have been developed by in the USDA and the CIMIT in the tropical in the cooler part of the world, and they were mostly bred for the disease resistance, sir. So when we see the HPR point of view, the disease resistance work just opposite to insect resistance, and there will be a crosstalk. So that's why most of the material input lines we screen, we don't get good resistance material. If we get it, they will be low yielders. They are not agronomically superior. So most of the disease resistant lines, they are agronomically superior, but not the pest one, especially for the chewing one. So it is
Yes.
because of our breeding occurred, the evolution of corn occurred in the temperate part of the country. So we have to deliberately evolve such corns in the germplasm in the tropical part. But in yes, USDA had, and also the MO series, MP series, also the CIMIT had the CML series,
CML 338 is a good
yeah,
source. It's a
338
good source. Yes.
and the CML 60, 59, so many are there, but even they have not used it. So that we have to use, because when they got it, the transgenic corn came, sir. So I'm not in favor of transgenic corn, because it is even, if we are pyramiding, are the number of pyramiding is going on, and it is CRY1F wherever it is, the only thing which is working is a three-way pyramid, because I think CRY1 AB, CRY1 AC, CRY2 AB2, and with 3A. This three combination is the one which is working and which has not developed much resistance. So that happened in a period of 30 years. So that how long it's not a sustainable solution as from a person, my perspective, who closely observe how the insect, how they rapidly evolve. We are unable to adapt, but they are able to adapt in any kind of environment, any kind of food material. That's why they are very polyphagous also.
Okay. Okay. Thank you.
Thank you.
Thank you so much, madam. We keep learning from you. हमेशा हम आपसे सीख रहे, और कोई अगर वीडियो, अगर ये जो वीडियो है हमारे IMR के YouTube चैनल में भी है, तो मैं लिंक शेयर कर दूंगा कल चैट में. तो अगर कोई मिस आउट हो गया है, कोई दोबारा सुनना चाहते हो, तो हमारे YouTube चैनल में भी आप जाके सुन सकते हैं दोबारा ये वीडियो.
ऑलरेडी शेयर कर रखा है
हाँ,
अपने ग्रुप में.
तो ये आपका दोबारा विजिट कर सकते हैं एनी टाइम. तो थैंक यू सो मच वंस अगेन मैडम फॉर सच अ नाइस प्रेजेंटेशन मैडम. थैंक यू सो मच मैडम.
Thank you.
कल मिलते हैं फिर.
Yeah.
थैंक यू सो मच मैम.
थैंक यू एवरीवन.
थैंक यू.